Hi guys, in this lecture we're going to be talking about line and edge features. Okay, so a line feature is a straight line or straight edge in an image that usually denotes the boundary of an object. So the calculations involved for identifying lines can be a bit complex. The reason is because an edge is really a list of xy coordinates, and any two coordinates could possibly connect by a straight line. As you can see here, we have four dots. They can be connected in this configuration or in this configuration. So what is edge detection? So edge detection is the name for a set of mathematical methods which aim at identifying points in a digital image at which the image brightness changes sharply or formally has discontinuities. So the points at which the image brightness changes sharply are typically organized into a set of curved line segments, termed edges. There are a number of edge detection algorithms that we can use to obtain these edges. So there's Kenny edge detection, Dirichlet edge detection, differential edge detection, Sobel filter, Prewitt filter, or Robert Cross. As you can see over here, what happens when we use edge detection. We are left with only the important features, such as the eyes, the mouth, the hands, and basically stuff in the background has been discarded. Okay, so why do we do edge detection? Why is it important? Well, basically, we want to produce a line drawing of the scene from an image of that scene. Basically, important features can be extracted from the edges of an image, such as the corners, lines, and curves. These features are used by high-level computer vision algorithms, such as computer recognition. If you look over here in machine vision, we want only the edge of these lines, and by using edge detection, we can basically calculate these coordinates and thus calculate the perimeter of this object. Or we can calculate the diameter of this circle object. And these are just some basic applications of using edge detection. Speaking of applications of edge detection, there are a number of useful applications out there. One of them is such as lane detection. By using edge detection, we can detect the dark to bright intensity discontinuities along the road. And from there, we can draw a line which denotes the edge or detected lane within the image. And we can do inverse proportional mapping that gives us this straight lines over here, sort of like a bird's eye view of what we have detected. And then we can also use it for optical character recognition or OCR. As you can see, this is a LAVI program that is used. So we use edge detection just to extract the important features, and we can discard all the other noise in the background. This also helps us to do pattern recognition or matching so that we get the desired alphabet or number. We can also use edge detection for automated target recognition or ATR. Say we viewing a tank coming towards us. We can either use an infrared camera to detect the heat signature of these tanks. And by doing simple edge detection, we can detect the light to dark intensities, discontinuities, and then we can segment this object or target from the background. Another application is using facial recognition. Now, if you apply the edge detector, we are left with the main features, which are the eyes, the nose, the mouth. Using these features, we can calculate the distances and create a profile for this facial image, and thus detect the face or recognize a person's face. And then there's also vehicle detection and verification. Using edge detection, once again, you can see it's quite noisy, but once we've detected this region of interest, we can use it to verify if this object is a car or not. We do that by using symmetry. So if the histogram of this part or the left side is identical to the histogram of the right side, we can verify that this is a symmetrical image and thus could be a car. Okay, so let's look at some ideal edges. So if we take this as our dark pixels and this is as our light pixels, you can see it's very sharp and it's very easy to identify our edge. Over here, it is easy as well because we can detect this ramp very easily, and it's very distinct between the bright pixels and the dim pixels. So this is a ramp, this is a line, and this is a roof. Now, real world images are noisy and they contain a lot of noise depending on how the image is taken or how the video was taken. In this case, we are unable to identify between a step or ramp and between a line or a roof. And basically, real world images contain a lot of noise, so this is a challenge in computer vision. If you look at the machine vision application, this is the edge profile. So this is the histogram of the intensity of this picture. You can see the bright pixels are quite high, and as we reach the dark pixels, they become quite low. And over here, you can see this gradient over here. It's semi-bright. It's like somewhere in the middle, mixed between white and black. And then we go back to the white pixels. We can also use this distance over here to calculate this diameter, should we wish to. And then the same thing happens on this side here. So you can see the original image has a lot of noise. And our edge profile, which is basically our intensity histogram, we can see that the edges are not perfectly sharp. Okay, let's just take a look at some edge detection terminology. So an edge point is the point at the location of a local intensity change. An edge detector is an algorithm that computes the edges in an image. A contour is a list of edges or the curve that matches the list of edges. And edge following is the process of searching the image to determine contours. Okay, let's look at some vision-based apps that we shall be building in the following lectures. This is going to be 2 parts of one app. One is basically the edge detector. So basically, we're going to be using edge detection to measure the width of a ruler. Now, it's quite a simple application, but it's quite important because if you're using it for machine vision, you maybe want to calculate the volume of a bottle, or if you want to calculate how much liquid is filled in a bottle, you can also do that with machine vision. And our second part of the app, which is a simple lane detection. So we're going to basically use our vision assistant to find all the edge points along this lane or along this region of interest. And then once it has detected all these edges, and basically use our list of edges to draw a line along there. Okay, so that's it for edge detection. Let's take a look at the recap. Okay, so edges are basically local changes in the image intensity. The edges typically occur on the boundary between 2 regions. So edge detection can basically be used to find the important features for image analysis. It is important to note that the edges due to noise are not edges, and real images are very, very noisy, and it is difficult to find edges in the noisy images. And also, finally, the changes due to shading are not edges. Okay, so I hope you enjoyed this lecture. We didn't get into anything too technical, but in the next lecture, we shall be delving into creating our vision-based app. Okay, see you then.